All right, thanks, Nick. And thanks to OWI for the invitation to come here and share PrivaKey with you today. We good to go?
Yep.
Okay, cool. So when you think about today, customer authentication is really a tangled web across all of the different channels. For instance, when I log in, I'm online, I use a password. If I'm calling into a call center, I'm interrogated with KBA. I might be receiving a fraud alert through text. And for higher risk transactions, I may be using some kind of out-of-band code. And all of those experiences are really neither convenient nor are they consistent. And so what PrivaKey delivers is one consistent way for customers to both assert their identity and then provide really strong consent that works the same way across all channels. It's really the same process every time. So PrivaKey binds users' identities to their devices and then really turns them into strong authenticators that can be used across all channels and really enables the use of biometric identification across the entire customer experience. So customers really enjoy the fact that they can use biometrics really everywhere. So in the demo today, we're going to share how PrivaKey improves really a banking experience. But the use of PrivaKey is really not specific to financial services, just to put that into context. And we're going to start with a really simple example of using PrivaKey to log into the bank's website here, the Bank of Tomorrow, without a password. So here Jessie's going in, and she's going to use her email address to identify herself like she normally would. This is her phone over here on the right. And as she goes ahead and log in, you're going to notice that she's going to get a notification on her device saying the Bank of Tomorrow is requesting authentication, which she's going to approve, and then use her Touch ID as a second factor to really verify that it's her logging in. And once she's done that, the bank website will then return her back into an authenticated session. So, we've eliminated the password, delivered a better experience, and really improve the security by delivering a true, multi-factor authentication. So the next example will be to show, how does PrivaKey really improve the call center experience? So when you think about a call center today, if I call my bank or an institution, I'm really interrogated by KBA, and it's an experience that is a hassle, it's time-consuming, and it really comes from a position of mistrust. But with PrivaKey, the IVR, the call center system, is going to identify that it's Jessie before she ever reaches an agent. So in this case, she's calling the Bank of Tomorrow, and imagine she gets a notification that was sent to her. And as she goes to respond to it, you're going to see it's going to look a lot like the first authentication, but this one's a little different because it's asking, please confirm you're on an active call with the Bank of Tomorrow. So the context is there. The actual response is exactly the same way. She's going to go ahead and approve that. And again, using her Touch ID. So a much better experience, no interrogation, and faster, and the agent didn't even need to get involved. Our next example we're going to share is really an emerging use case, and it's the ability to offer and deliver higher risk transactions, higher value transactions on voice-controlled devices like Amazon Alexa. Today, Alexa and products like it are really limited in the skills that people offer. What's my balance, sort of a lookup. But in this example, imagine that with PrivaKey involved, you can say, hey, I want to transfer money from account A to account B. Something that's risky today, but with PrivaKey's higher level of customer identity and customer identification, now you could have something like, hey, please confirm you're transferring $10,000 from checking to savings at the Bank of Tomorrow. That would be prompted from Alexa. Again, Jessie's able to respond in exactly the same way. So it's really an opportunity to create higher value transactions on voice-controlled devices like Alexa. Okay, so now that we've shown you 3 examples, let me just share sort of what's going on here with PrivaKey. So PrivaKey is really a very lightweight software solution that's comprised of desktop and mobile libraries that are really intended to turn existing, say, mobile apps into strong customer authenticators. So the customer is not likely to see PrivaKey, they're just going to now see that say the mobile banking app or your mobile app now has this ability to be a strong authenticator. So we have the mobile libraries, and PrivaKey also then has an Auth Service. And Auth Service is really there to take challenges from any existing service. It could be a user-initiated action like a login, like my example. It could be from a IoT device like Amazon Alexa, or it could be the call center. But really, all of those different challenge, different challenge origins are really just interfacing with our Auth service through a simple RESTful API. So you can really anywhere you could dream up, hey, we want to be able to get strong consent from our customers. You can simply interface with our Auth service, which is then going to broker those and send out those challenges, in this case, to Jesse's devices. Okay. So here's Jesse's phone again, and here's another example. There's a suspicious transaction. Let's see what that's about. Uh-oh, so the Bank of Tomorrow is requesting her approval. We've frozen your card after detecting a suspicious $1,500 purchase at the Apple Store in Miami. Please approve or reject this pending charge. Well, Jesse?
Yeah, I'm clearly not in Miami right now, so I will reject that. That was pretty easy, just the same as all the other transactions.
Right. And when you really think about it, what PrivaKey delivers is the ability for a customer to really strongly assert a yes or no. But that yes or no could be really, a response to anything. Okay, so the examples we've shown so far have really been sort of consumer, sort of retail, customer-oriented, but there are lots of business and enterprise applications of PrivaKey too, like this quick example of a payroll disbursement. So imagine I'm the CFO or treasurer of an organization, and there was some kind of workflow. Maybe, Jesse has prepared a payroll, but it's my job to sign off on it. With PrivaKey, I don't have to go in and log into an actual online. I can just get a simple notification saying, hey, please approve the payroll disbursement of $45,000 for the engineering department. I can sign off on it, and yet, it's easy for me to sign off, and it is, clear that it's my identity and not someone else faking it through the two-factor and through my biometric. Okay, so let me share a little bit more detail about PrivaKey. So PrivaKey supports the use of the native device biometrics on Apple and Android, like Touch ID, Face ID, and fingerprint. For older devices that lack biometrics, PrivaKey supports the use of a PIN. In examples where, for instance, imagine that Jessie might have 2 or more of her devices, say with a banking app installed on them, she will get those challenges or notifications on all of her devices and can respond from any one of them. So really, in closing, when you think about it, you have PrivaKey really provides the ability to improve the customer experience today. And a common rollout of PrivaKey starts with solving sort of one troublesome or problematic interaction. In many cases, it might be like the call center, customer identification. And then once PrivaKey is in place, it's easy to add on those additional challenge sort of origins to extend the utility and value of PrivaKey to more and more use cases. Okay, so thanks for the opportunity to share PrivaKey with you, and I think we have a minute for any questions.
So really quick one. On the screen you had a code that was on the website and on the mobile device.
Yes. Yeah, so that's really just there for, say, an over-the-shoulder attack.
Yeah, sure. Yeah, that's an implementation we've employed as part of our library as well. And that is, as Pat was mentioning, for an over-the-shoulder style attack. Just making sure that if there were simultaneous requests for the same exact action, you could display a code that you could present on the screen and on the device so the person knows they're acting on the right one. So that's what that's meant to be a defense against. So, yeah.
So, 2 questions. First is your authentication only app-specific or device-specific? Because I see you guys are only using whatever device offers, like the Face ID or a Touch ID. There is no specific face where the Face ID is not involved, or the voice, or other kind of biometric authentication.
Yeah, this was designed on purpose to leverage the biometrics provided by the device manufacturers and supported by the framework OSs. So that's because user familiarity with them. It also allows us to just interface with the framework instead of having to implement specific libraries. So.
Okay. The second question is, what is your enrollment process? How do you guys enroll devices and the customers to this platform?
Okay. Apologize. I was supposed to repeat questions, and we are out of time. So I will answer that at our booth, which is right out there. Sorry. Yep. Thanks. Yep, sorry.
Thank you.
Thank you, PrivaKey. And just a note for all presenters, please repeat any questions. That way, no worries. But just that way in the future, we can actually have them recorded. So thank you. Yeah, no worries. So up next is going to be NuData Security. And I don't know where he went. Oh, there he is.
I'm here. Perfect. Start whenever? Talking the mic. Now, hello, everyone. My name's Ryan Wilk. I'm the Vice President of Customer Success for NuData Security. NuData Security was recently acquired by MasterCard, as you can all see there, so we're a wholly owned subsidiary of MasterCard. What I want to talk about today is a bit about passive authentication, passive verification. We talk a lot about how we understand the user in the digital world, but how do we understand not just that it's the correct device, that it's potentially the correct person clicking a button on a device, but how do we determine it actually is the correct human behind that device? You know, that all-powerful holy grail of saying, you know, is this actually the person who should be linked to these credentials? So it's really that giving you that power of understanding your user. So we're going to jump into my demo here. Okay. So to give you a little bit of idea of what NuData is and the NuDetect platform, NuDetect takes a multi-layered approach to understanding the underlying intention of a behavior in the digital world, whether that be a website, it be an API, it be a native app, really looking to understand, is the intention of that behavior malicious or is the intention of that behavior valid? We take this multi-layered approach here, looking at all of the various different non-PII and non-PCI aspects of a user's interaction. So very similar to the physical world, where there's aspects of you, the way you dress, the types of car you drive, the way you go about your day, very similar things in the digital world that make up that persona of your behavior. The layers include device connection and location. I think device ID and geolocation intelligence is pretty basic. Everybody understands that. But I think it's still extremely important in understanding who that user is. The second layer we look at is behavioral analytics. And NuData looks at behavioral analytics from two different dimensions. The first being the individual user. So each time that user authenticates, there's lots of data collected around them. What we can do is use that data to now understand what's the likelihood this is the same behavioral pattern we've seen for this user in the past. A great way to think about this is, you know, last time you were on the site, you were on Safari, you're on a Mac version 59. This time you've come back, device ID is gone, but you're on version 60 of Safari. There's a natural behavioral progression. We're also looking at the full environment, looking to understand how every single data point corresponds with every other data point in the environment to look for different types of statistical abnormalities, looking for subpopulations of behavior that are standing out to better understand what is that behavior doing. The third layer we look at, and this is the one that I'm going to actually demo today, and I'll need someone from the crowd. You know, I know you're not all going to jump up, but I'll make somebody come up sooner or later. But passive biometrics looks at how the user is actually inputting into the device. So bringing those aspects of the physical world into the digital, things like typing speed, keystroke deviation, do you mouse, do you tab? When you hold your mobile device, do you hold it in a right-handed configuration? Do you hold it in a left-handed configuration? Being able to pull all of these real-world aspects around you back into that evaluation. And what that does is it allows NuData to do two really core things. The first is we can identify very complex types of automation. Many different tools on the market today that identify automation, identify different types of credential testing or account takeover. A lot of those tools live at the network level. They're looking for volumetrics, or they're looking to potentially obfuscate things like HTML. Well, if you have very basic bad actors who are just trying to script the HTML or script an endpoint, sure, that will work. But the really complex and the really sophisticated bad actors are scripting the browsers. They're scripting the actual apps. And by doing this, they're bypassing all those controls. They're looking as human as possible. If you don't have that visibility at the actual client layer, the browser or the app layer, you lose all that visibility, and all those bad actors walk by you without a second thought. The second thing NuData does with its passive biometric verification, and this is what I'm going to be demoing in just a moment, is our good user recognition. So each time a user inputs into the device, they authenticate themselves. We collect all of those various different physical input data points that I was talking about. We can take those data points and build out profiles for the user. So saying that this is the input profile for this user, and a user being an account name within the digital world. So that each time that user returns, we can look at the pattern that they input and say with a degree of confidence, is this actually the correct human entering these credentials, or is this human now deviated from the historical pattern? Again, not necessarily saying that as soon as you deviate, you're a fraudster, but it's a new layer, it's an extra layer to really help with that continual verification of the user. And the final layer we look at is our real-time trust consortium. I think most vendors here offer a trust consortium, offer some sort of consortium. If you don't, people look at you and say, why don't you offer a consortium? Extremely valuable. To give you an idea of our size, NuData processed over 200 billion behavioral events last year. So a massive amount of data flowing through our system, we believe to be the largest behavioral network in the world. And by combining all of these layers, that's really where you get the power here. You know, you think about going out and trying to buy these various solutions, and I know I've done it in my former life when I worked in the e-commerce risk space, trying to get out that technological duct tape and put all of these together. By having a truly integrated solution that looks at the idea of identity and looks to verify your users, even as various different aspects of these layers fall off, device ID changes, behavior slightly different, you can start to ping pong off of each of those to really get a strong understanding of who that underlying user is. So now let's jump into the demo. What I'm going to demo for you is specifically NuData's passive biometric typing capability. Again, this is a small aspect of what NuData does, but I think it helps really visualize this and get a better understanding of what's going on behind the scenes. So this is where I'm going to need a volunteer. So does anybody want to volunteer? Look at you all jumping up. So you want to volunteer. There we go, you know. So what I'm going to do here first is I'm going to type this in. This is a randomly generated username and password here that I've not seen before, so I'm not trained on this. But what we really want to see is when I log in first, and then Nick. I was going to do Rick, you know, it was one or the other, I just didn't get it. But he's going to then log in, and we're going to see how our patterns deviate. So let me go first. Now you log in? That's the username and password right there. No, I don't want to make it easy at all. And really, one of the ideas of what we're doing here is when you start to think about how you enter your credentials on a website or in a native app, it's almost automatic. If it's the website, your hands touch that keyboard and somehow magically it comes out of your fingers. If you're on a native app, somehow, you know, your thumbs are doing all types of craziness and the configuration you hold that phone. Very unique aspects to who you are. And now we can start to see how unique those aspects are. So what we have here is we have a visualization of both of our input patterns. Again, this is just typing. We're not looking at everything else that can be collected. So we see here, me as the first user, I have this very kind of, almost like the golden arches right there pattern. And we can see Nick as the second pattern has this kind of arc. So it's a very different way in which we input into the device. By taking this, you can now get really complex around how you understand that human behind the machine. You know, when you start to see similar patterns, they start to lay on top of each other very similarly. You start to have that very tight correlation. You know, here's that idea of an imposter, and I think we showed that pretty clearly here, what that idea of an imposter looks like. And then as I was talking about different types of automation, either, you know, simple bots where you just see one input and that's it, or very complex types of automation, things like GUI overlays that are sitting on top of the browser, attempting to make it look like it's as human as possible. So really being able to better understand that underlying human in the digital world. So I know we have a couple minutes left. I'd love to take some questions if there are any.
Yeah, I think these were two great examples of differences in patterns. Can you give a sense on an aggregate, false positives, or how the quality of these behaviors for identifying bad actors?
No, sure. So first, to identify bad actors from these types of patterns, first you want to recognize who's your good actor. And this is where that idea of the multiple layers really comes in. Because, you know, you think about this, and, you know, we have our typing patterns, but you might have had a good night out last night, right? And you decided to check your bank account, and you're like, ah! Or, you know, you have the kid grabbing your one arm, and you're normally typing with two hands versus one. That's where the multi-layered approach really becomes extremely valuable, where we can say, okay, the passive biometrics changed, but we see it's the same device, same IP connection, and the user's not doing anything risky from a behavioral standpoint. Now we can start to invert that. We can see, okay, there is a difference here. We see that Ryan has always logged in on a Mac, and now we're seeing that it's an Android device logging in. We're seeing that he's coming from a geolocation that's different than what's expected. So using that correlation of the pattern across all of the behavior really lets you determine when that risk occurs. Thanks. Sure. So the question was, how long does it take to get a baseline on the patterns, on the 4 different layers? So if we're looking for risk, it's almost immediate. Risk is a definite outlier from what is valid. So you know, depending on what use case we're looking to solve, say it's human from non-human, it's very easy to identify what's non-human. Now, when you're trying to verify, is it the correct human time and time again, that becomes a little bit, you know, you need to learn who that user is. Traditionally, we require between 5 and 10 login events to build that profile. There's obviously some nuances there. If you know, those 10 events happen in a half a millisecond, you know, that's not good. So, but it's between 5 and 10 to build out that profile of the user. And I think we're just a little over, right? I think we're good. Well, thank you, everyone. Come stop by the NuData booth. We have the demo there. You're more than welcome to give it a try, play with it yourself. But have a great day. Thank you.
Thank you, Ryan. And next up, we have ID Analytics. So.
Now I've got to relog in. Okay, I think we are almost ready. HDMI. Welcome, everyone. Sarah Ball here with ID Analytics. To tell you a bit about us, we were founded in 2002. The original couple of data scientists who helped develop the Falco algorithm for the FICO score, then sold that off to the other credit companies for them to use and said, what if we did the same thing, but with the express intent of building a fraud prevention and ID theft protection consortium. And so that's what began back then. And we're now have over 450 enterprises in our network, including the 8 of the top 10 banks, 4 of the top wireless carriers. We've got marketplace lenders, auto lenders, a number of folks that actually give us visibility in what we would consider nearly 100% of the U.S. consumer base. And that's important because this is the power behind our solution that is we use for digital enrollment. So we've got over 2 billion historic high-value consumer transactions. The 4.2 million reported fraud identity attempts is important because that's the largest one in the U.S. And you use it to then, when someone comes online and it is a fraudster, a potential bad actor, we can immediately check that database and see if we've seen them before and in what way. We get over 113 million new identity elements per day. These are in real time. So it's constantly updating. And we are also the engine behind LifeLock, if you're familiar with LifeLock. And that gives you that immediate view wherever in the network someone is applying for credit using your credentials, your information. And we can immediately say, is this you or is it not you, across all of those consumers. So that's sort of what's behind this. Let's talk about how we use our solution when enterprise customers are looking at an easier way to make the application process simpler for online and digital access. They often go to a photo capture solution, and that's a great one. With us, we call it ID Connect. And I'm going to show you the demo first, and then we'll talk through kind of what's underneath it. That sound all right? Okay. Switch. Make that a little bigger. So this is a screen that you would typically see, which would have your colors on it. It's integrated into your own online web app or mobile app. It's not something that was required to native app download to the user's phone, so it's very accessible. So we would first ask for access to your camera. They would then can do either driver's license or a passport. I'm going to show you my driver's license today. Don't let anybody steal that. And image processing failed. Of course. And now I'm going to log back in. Because demos are fun, aren't they? And we are part of Symantec. They bought us out last year, and as part of that process, they are a global cybersecurity company that requires lots of layers, even on our own demos. But it's for our safety, so that's okay. So I'm going to allow access to the camera. We're going to take a picture of the front. And a picture of the back. And are you all familiar with why we do that? Most people here seem to be very savvy about that barcode on the back and why it needs to match the information that's on the front. An extra step that we do is also asking you to say, who is the issuing state for that license versus the transacting state for where you're actually applying for the loan or seeking to open an account with a particular business. And that is because each state has its own regulations. They can decide whether you're allowed to capture that ID, to use it for this purpose. Can you store it in grayscale or full color? Can you only take the data? There are a few states that won't let you use this at all. And so part of our solution is to give you that compliant set of business rules behind the scenes so that you don't have to think about that and figure that out as an enterprise. So you can see here we've extracted the information from the ID. In addition to what's on the ID, ID Analytics can provide also full social, phone, and email. When we resolve that identity, we're able to give you a complete picture of all that information. But in addition to that, we're also checking to see what other insights we can gain. That network we talked about, the 15 years of watching out for fraud and learning how to do this in real time across application data as well as performance data from all of those banks, wireless carriers, utilities, everyone out there, gives us this information back to say, look, the PII on the front of that card doesn't match what's on the back, or it is Sarah Ball, but they've changed the date of birth. We've never seen her at that address. Things that fraudsters typically will use to come in and cause issues. And I see now that a lot of fraud managers are dealing with people, when you do capture an ID, they scan it and fax it or email it in, and they're looking at a piece of paper. It's very difficult for a human being manually to look at that and say, looks like a fraud or not. We're also watching to see, is it expired, or is it deceased? We're checking a lot of other data underneath. So let me jump back to the other to show you what's happening. Really? Okay, good. Okay, so this is a little bit busy. I'm going to kind of fly in on this slide a little bit. What we just did was talking about the consumer was requested from a link to allow access to the camera, scan the front and back of the photo. That comes back through the enterprise to ID Analytics. We do the photo capture extraction piece, and then there's a series of work that we're doing in the background We're doing for the resolution of the data, full PII plus SSN, phone and email. You've got the front and back alignment. You've got a cross-industry consortium of all the photos we've ever seen. So this is a proprietary technology we've been working on for a couple of years to say what are the biometric readers on that driver's license picture. There's a certain distance, certain lighting that has to be in place, and how do you know that's the same photo? And then we were watching to see how often we've seen that appear in our fraud database. So how often has it been used? When a fraudster gets hold of a good photo, they don't want to waste it, and so they do reuse those. We're also looking at velocity and how many times that ID has been used recently for applications across our network as well. That's an indicator that there could be an issue. We do all of this. Each of those calls are in sub-second, running parallel. It's usually 5 to 10 seconds total in latency before we give that information back to you. And then you can present back to the client. Once you've got those flags from us and we've said it's a go or it's a no-go in terms of fraud, and then what you present back to that prospect and how they go forward. There's one other piece of this, though, because now that we've got that information on the photo ID, we want to make it available for fraud managers in the future to be able to look up. And this is something unique to ID Analytics. We give you a research tool for reference and for lookup. You've got these IDs, and most of what we're seeing out there is our banks and our enterprise clients don't always want to keep those because it's yet another piece of PII that you're now subject to becoming a target on. So we actually put them up into a cloud for you and take on the responsibility for keeping those safe. But you can do a simple document search, looking for a transaction. And all the data as well as the photo are on those. So we have what we call a caution list. That's a multi-tenant cloud repository. You will experience, or your enterprise clients will experience, an occasion when someone comes in and is fraudulent. They discover that even if they looked fine on the front end, they've now become someone to watch out for. You want to add that to the caution list, and part of our consortium is everybody gets to share on that one. You get the ID numbers. We're not going to share your specific transaction detail with other enterprises, but anyone can go in with a driver's license number or passport number and say, is it already out there? Gives you more confidence to say, okay, our investigation says this guy's a fraud. Now we confirm it in our consortium that it really is out there, and you can add to it. So you're actually going to help inform your other compatriots in the fraud prevention network. So this is one where we actually saw 6 different photos with 21 transactions and 13 unique identities. And that was just last year on one of our fraud incidents that occurred. And that's the sort of data that we'll have in there available. So we talk about the ID Connect allows you to pre-fill the application. That's a great customer experience. 95% plus of your customers are good actors, and you want to give them a happy path, an easy way to not have multiple pages of information of PII they have to fill out. So this is a great way to go about that. We also want to prevent the fraud, though, of those few that are not good actors, and then enable the investigations for later. So what are your questions? Oh, yes.
So in this demo, it's like the person can fill the information one by one, right? Is there any like a batch mode you can enable for a person or a company to start validating the data?
Yeah, well, for verification of the data that you have,
Yeah.
we would. What I'm showing you today is more the consumer, the front end when they're applying themselves. But certainly from an enterprise perspective, we can do the batch verification as well. Yes.
What are your plans to extend beyond the U.S.?
Sorry?
What are your plans to extend beyond the U.S.?
Currently, we're U.S. only, but with our acquisition by Symantec last year, you can imagine there are already plans for international expansion. This really is about a consortium model, and so we sort of have to go region by region and build that consortium out and have folks join in who want to do this work with us. But yeah, that's already, they've got mapped out kind of where we're going to go around the globe. And I'm done. Thank you.
Alrighty, thank you, Sarah. And up next, we have NuID.
I'll hold it. Thanks.
Hi, everyone. I'm Locke Brown. I'm the CEO and a co-founder of NuID Inc. And today I'm going to talk a little bit about trustless authentication and trusted identity. I'll explain what these mean and how together they can actually provide for a new global interoperable identity system. I'm also going to talk a little bit about two technologies, blockchain and zero-knowledge proofs, which together provide for a kind of new paradigm in how we think about risk in and trust in digital security, and providing that we actually have a new foundation in authentication. And so to get started here, first I want to talk about something that we probably all are very aware of, and this is the kind of current prevalent model for identity today. And so it's siloed, and what that means is we have the businesses over here. It's centralized, right? So every company that we as individuals interact with are actually having to trust that company to store user credentials. And that company has a massive risk in actually storing these credentials on large siloed databases internally. And we all here probably know that security is a 24/7 job. And just because you're secure today does not mean that you're going to be secure tomorrow. And then for the user, they always experience a fragmented identity system online because you, as a user, have a different digital representation of yourself on every system that you actually use. So you have different accounts everywhere, and every different service you interact with has a digital representation of you there. So you have to remember all your passwords, but you also have to trust every single one of these companies to actually protect securely your authentication data, which we all know doesn't always pan out super well. And so before kind of moving on and talk about what NuID is doing with trustless authentication, I wanted to first define this word trustless, as it's really kind of a new word that's come about with the advent of the whole blockchain world. And what it really means essentially is just a system that does not require trust and between a user and another party. And so here at NuID, we're really building a trustless authentication solution. And what that really means is that users do not have to trust the parties that they're interacting with to actually store and secure their data. And you might be thinking, well, how is this actually possible and how does this work? So I'm going to give a quick, high level. There's two real novel advances in these technologies that allow this to be possible, and it's in zero-knowledge proofs and distributed ledger technology. So a zero-knowledge proof is really a small program that can be generated based on some secret, such as a password or a fingerprint or any other sort of repeatable data, including a hardware security token. And what happens there is this little proof is generated using this secret on the fly on a device when you first register, say, some password or other authentication factor. And what it allows is for that the public aspect of this proof to be out anywhere in the open on, let's say, a blockchain, and it can actually then be used to verify that the original registrant actually knows that data without ever revealing the underlying data to any other party. And so this, coupled with blockchain technology, which is characterized by being a distributed immutable ledger, allows for individuals to actually authenticate themselves from any device, anywhere, without trusting anyone else, including us here at NuID, to ever be able to see or access any of that underlying authentication data. And so just to kind of wrap that concept up, if I was going to sign up for an account at Bank A who had implemented the NuID protocol, I would then be prompted on my device to enter a password, let's say as an example. And on that device, a zero-knowledge proof would be generated based on that password I have put in. And then that proof would then be actually registered via block transaction onto a distributed ledger upheld across all the nodes on that network. And then in the future could be sent to any device that I'm trying to authenticate myself on for me to then recomplete the proof by providing the underlying secret that I originally registered. So if I was able to successfully recreate either that password or fingerprint or whatever sort of authentication factor I registered, then that proof would basically say validated and then move on through our REST API to actually generate a single session token that authorizes you to interact with the service that you're trying to use. So furthermore, many different authentication factors can be registered, and all of these can be specified to be required in some combination or thereof by the user or the actual company to provide a multi-factor experience that's very seamless and accessible from any device for you to actually authenticate yourself. And so trusted identity is kind of the second part that I mentioned here at the beginning. And one thing before I kind of get into the benefits of a trusted identity piece of this network is that to ever have a trusted digital identity online, you have to have a rock-solid authentication foundation. Because if someone else can authenticate themselves as me, say has stolen a password or was able to ever have breached fingerprint data or anything else, then how can anyone ever actually trust the digital representation, the digital identity that they're claiming to be? So trusted identity has to be based on a rock-solid foundation of authentication. And once you have that, then you're inherently secure because of the authentication aspect with your identity. But you also then have this aspect, because of the blockchain, of being portable and immutable. And what that really means is that you can port your identity to many different services, effectively having what we'd call a single sign-on to the internet. Because you would actually have full control over what factors allow that digital representation of yourself to authenticate you into these different services. Like I said, this is a foundational layer to the internet, and it's interoperable. And it's immutable because of the blockchain, meaning that no one can actually tamper with your actual authentication data because there is no single point of failure and no central authority that actually has control over or any power to erase, change, or edit whatever that underlying data may be. In this case, zero-knowledge proofs, which if they ever tried to edit anyway, would be completely useless. And then lastly, and probably most importantly, it's personal. And when I say personal, not only do I mean that you are truly in control of your own authentication data and identity as a result of the underlying authentication mechanisms, but it also follows you around. So we like to use this concept of bring your own identity, BYOI, where you are your password effectively. So whether you're super paranoid and want to say, require 10 fingerprints, a face scan, behavioral factors and others for you to authenticate somewhere and into something, you can actually use any device anywhere to do that because of the distributed nature of this system. And so putting this all together is what really allows for all the benefits of having this global interoperable system. And the biggest benefit, and the main one, as I've mentioned, is that it eliminates wide-scale credential breaches entirely. And that's because there's actually no authentication data being stored anywhere, particularly stored in large siloed databases within companies, as they often are today. And companies should not have to bear the burden of protecting user authentication data continuously. It's costly, it's expensive, and they could, many companies get hacked, and they don't want to be the next large hack in the news. And so really what this type of system does is return authentication data ownership to the individual and create a streamlined authentication workflow, which basically a company can drag and drop, for instance, the NuID libraries, where basically they'd have OAuth right now or other type of authentication solutions, and then pretty much not have to deal with ever storing or securing user authentication data, removing that burden, that risk, that cost, and just have a very simple, streamlined user interface in which users interact with. That company then can have a single representation within their software stack of each individual that they're interacting with and request any other sort of data from them as they wish. And the user would then have the choice and option on whether or not to authenticate themselves and supply that data. And so, I think we're all probably tired of the password fatigue and are looking to biometrics to really save us from that moving forward. However, if you have to trust every company you interact with to still secure your biometric data, first time that's hacked, that biometric is out the window and you can't reset it like you do a password. So I know I'm out of time here, but we actually just finished our kind of first demo that will be publicly available here in the coming weeks and accessible on our website at NuID.io. But also feel free to drop by our booth in the Startup Alley over here and catch myself or any one of my colleagues if you want to learn more. So with that, thank you.
Thank you, Locke. And the final presentation for today will be done by Intensity Analytics.
So let's see if we can fit a 10-minute presentation in 2.5 minutes.
I think you got.
thereabouts.
I think you got the full time.
All right, that's fine. Great. All right, so I will try to go through this pretty quickly, and rather than tell you everything about what we do and all the technology that we have and so forth, I'm going to try to go just into a slideshow that doesn't auto-advance. Sorry about that. Just a single example of what we do, and show you a very quick demo. Yeah, I'm sorry about that. All right. So since I do tend to walk around a lot, I'm just going to put that up there and talk a little bit more loudly than normal. So I'm Tom Ketchum. I'm one of the co-founders of Intensity Analytics. And as I say, I'm going to go through just a single example of about what we do. And that's OK. I can see that. Yes, exactly. Go through a single example of what we do and a little bit about a single use case, kind of how the user would see us on a regular basis. So I titled this quick presentation, as you see, Identity Solved, which is probably a pretty bold thing to say in an identity conference full of a room of people that think about identity a lot. And so, as you've already seen, kind of, it keeps wanting to go to the next slide. So let me show you what we consider to really be the perfect solution for identity, truly solving the identity problem, which is, in fact, just this. If the doctor that delivered you were to simply follow you around for the rest of your life and go, yep, that's them, that's them, that's them, that's them, it's the perfect solution. It is infallible, it is continuous, and it never breaks. But of course, it's not particularly scalable, it's not particularly economical, it's not particularly plausible. But in fact, if you really think about it, other than your mother and the doctor that delivered you, everybody else is in fact taking somebody else's word for who you really are. So a different solution then, an MRI machine. So every time you want to access your device or log into your computer, just crawl into this and we'll just scan every fiber in your body, and right down to the molecular level, we'll know that it's actually you. Of course, once again, this is millions of dollars per user. It's not particularly scalable. It requires armies of technicians in order to operate it. And if you want the very definition of user friction, this would be it. So we needed something more portable, more inexpensive, more scalable, something maybe a little bit different. So we would propose this, the privacy box. I actually have my privacy box with me. Yes, it's a prop show. So here's my privacy box. This is what we have for identity today, really, because inside my privacy box here, I've got all sorts of things. I've got my RSA token, right? I've got things like, this is all the applications and so forth that I use on a daily basis and all the things that I typically do on my computer. I've got my CAC card, my PIV card. Most of you guys here in DC are familiar with this particular smart card. And I've got things like my mother's maiden name and all the details on her. I've got all my biometrics. I've got my fingerprints and so forth in my identity box, right? I've got all that kind of stuff. I've got my cell phone so that you can geofence me. I won't throw that on the floor. But you can see where I am. And I even have my first pet. But that is really what we're treating as identity these days. All these little pieces and parts, some of which aren't really even from me, they're things that are issued to me, that are in this box. Well, boxes are actually a really good way to keep secrets, as it turns out. Just last week, there was a sarcophagus that's been at the University of Chicago for 150 years. And they just discovered, lo and behold, there's a mummy inside. It's been there for 2,500 years. So it's a really good way to keep a secret. The problem is that people want to keep peeking inside my box. They want me to use that smart card. They want to have my biometrics. They want to have all these little pieces and parts. And once that gets out, of course, then people can steal stuff from my box. So we thought about this problem, And to borrow a little bit from maybe Dr. Seuss, we thunk and we thunk and we thunk some more, and then we finally thunk of something we hadn't thought of before. And that's this. Mickey Mantle. Mickey Mantle was undoubtedly one of the best ball players of all time. Could hit, could run, could throw, was really an all-around player. When he left the game, he pretty much walked away. He didn't coach, he didn't manage, and a lot of people said, Mickey, why don't you teach other people what you know how to do? Show them how to hit, show them how to really give that effort on the field. And his answer was pretty simple. I don't know how. So if you look at effort, that is one of the things that makes me the most me. I played some baseball, but I didn't certainly play like Mickey Mantle. But importantly, Mickey Mantle also didn't play anything like me either. It is very much about my effort. It is that magical, special moment where the physical world meets the digital world. When I touch a device, when I touch my keyboard, when I touch my touchscreen, etc., that is a unique moment. It is something that we use to not infer an individual. We don't correlate that with other data. We have an engine, a generalized engine, that can identify specifically in a deterministic way who a person is. So I said I'd keep this pretty quick, and I'm going to do that. So let me show you a demonstration of how this works in the real world, how this works from a user perspective. I only need a few seconds to show this to you. Now, we have a lot more technology, and I invite you to come by our booth and see some of that, a lot of integration that we've done with various platforms and toolkits and so forth. But I want to show this to you from the user perspective. And why is that? Because if it's not something that the user can use with really no friction in a matter of seconds, then they're not going to use it. And that's why we continuously see all of these different, sometimes very exotic demos of products that have continuously failed over the last several decades. So let me show you that. Now, I went ahead and actually pre-called on a volunteer here. So Doug Goldstein, who is the Chief Innovation Officer at Innova and a member of a group called eFuturist, is going to help me out here. And what I'm going to do is simply come over to this page here. We're all familiar with that, right? It's just simply my username and password. Your users do this all day long. Now, there's no agent here. We have, as I say, various integration platforms that are available. This is just our web-based toolkit that can be added to a web portal in a few seconds. So I'm going to enter my username here, and I am one of those foolish users that have left my
there's a sticky note right there.
My sticky note, right, with my password on the screen. And in fact, I think I do have it, or I did have it. John, can you grab me that right there?
Oh, I'm sorry.
I left my sticky note all the way on the other side of my room.
This
There you go. Leave it
on
all the
there.
way.
Can't
So
leave
here's
it
my
on there.
password, and you're going to see what Doug types here, so you can see that we're typing the same thing.
Case sensitive, right?
Case sensitive, yeah. So in this case, it's pretty simple. I have a pretty easy time remembering this. It's my name and a word transfer magic, one of our parent companies, and an exclamation point just for good measure, because we all know that good passwords have, upper, lower case, and non-consecutive characters and capital hieroglyphs and so forth.
There's so many letters in and an exclamation point.
There you go. So it goes through there, and it just sees that it's not him, all right? And so this is the other half of the demo. I type in that same thing, and it's still not me because I'm not used to typing in front of a bunch of other people. Sorry about that. And I need to type the right password. Sorry about that. It was always harder to be yourself when you're standing in front of a bunch of people. So that's me, right? So I took a second, just took a deep breath and typed it in. And that's it. And really for the user, it doesn't need to be any more complicated than that. Because if I have to do an extra step, if I require an extra device that maybe I've left at home, or maybe in my facility I can't take a cell phone into that particular unit, et cetera, then it adds friction, it adds steps. This is something I can already do. This is something I can distribute out to the consumer world in a matter of seconds and quickly solve that identity problem. So if you have questions, I know that we're basically up on the end of the time here, and I appreciate you all staying. We have a booth over there. I think it's 308 is the booth number. It's in that row of what we've called sort of the lemonade stand booths there on the side. Please stop by, and my colleagues or I will show you a demo. I appreciate your time. Thank you.